On this video, we will talk about some hints for some problems regarding the circles and lengths of segment practice assignment. So the problems that I do want to at least discuss or give you a better guidance are the last three word problems. And we'll start with act number 4, activity number 4. The problem states find the radius of the aquarium tank. So here we have a circle, and this is our objective. We want to come up with the value of this radius. One way to think about this problem, or at least the hint that I'll be providing to you, is that you might want to think about this problem as the relationship between this tangent line and the secant line. Because now notice that the secant line, it's made out of three parts. It's an r, this radius, plus the second radius, plus this little line segment, which is EC. So therefore, the secant can be seen as just 2r plus 8. Think about how a secant line, what's the relationship that a secant line has with the tangent line, which notice right now, the length of our tangent line is 20. For activity number 5, it states, the circular stone mound on Ireland called the New Grain has a diameter of 250 feet. So here you can think about it as being a circle, and we know the diameter. So from here to here, that's exactly 250 feet. Now there's a passage that is 64, it should be a typo, it should be feet as well, 62 feet. Which for that, this is the passage that we're discussing. So from here to here, that is 62, which leads to the towards the center of the mound. So this is the center. Now the question is it possible for us to find the perpendicular distance from x from the end of the passage to either side of the mound? In other words, is it possible for us to, whenever they talk about the perpendicular distance from x, or distance x, from the end of the passage to either side of the mound, we're talking about this. Is it possible for me to find this value of x, regardless if you're coming from the left or you're coming from the right? Now, my hint to you is, notice that there are two chords. In this figure, notice that we have two chords. The big chord, that is the diameter, and we can think about as this line segment from here to here to be another chord, which is, so we got one chord, which is the diameter, and we got the second chord, which is 2x, where from this point to here, that's 1x. So from this point to here, that's another x. Now, the way that you might want to think about this problem is there any relationship between two chords? In a circle. Think about it. So we have this big chord right here, and we got a second chord right here. Now, is there any relationship between those two chords? Now, lastly, I think here's another typo. Obviously, this is not 3, but it should be 6. And this is the last example that I do want to discuss, or at least the last example that I'll be providing a hint to you, which states PT is the tangent to circle O. So here we have the tangent line. So this is my tangent line. So, and we have a secant BA, which is perpendicular to PT. So now notice that we also are being provided with the tangent line. And I think like this might be another topic because it's exactly a chord. And I feel like in order for it to be a actual secant line, that should have been PB. So let's just change that. Line PB, which is the whole thing. So notice how here we have a secant line. I'm sorry, here we have a tangent line, and here we have a secant line. And the relationship is that they are perpendicular to each other. Now, we also know that there's a line segment TA, which is from this point to this point, which has a length of 6, and PA, which is of 3. Now, we are asked to find three things. First, can we define the length of AB? So at least our first objective is this. Is it possible for me to find the length from A to B? So this is going to be our first objective. Now, the way that we want to think about this is, first, we need to define the length of TP, which notice that it comes from a right triangle. So therefore, we can use the Pythagorean theorem to find TP. You find that value. Now that we know that, we're going to create this auxiliary line, where this auxiliary line is going to be a radius of a circle. So we can think of this as being the radius of the circle. Let's call this point X. And now AB, you can think of AB as being a chord. Actually, I'm going to call this R. AB, you can think of it as being a chord. And now think about it. If we draw a perpendicular diameter, a perpendicular radius, according to what we have discussed now on our previous lesson, is that if we have a chord and we draw the radius, and this radius is perpendicular to the chord, then these two line segments, A to here, this line segment, let me call this S, we know that AS is congruent to ASB. And once we have this relationship, don't forget that we're still talking about a tangent and a secant. And we know that there's a relationship between them two. And that is that if we take the tangent square, it's always equivalent to the outer segment of the secant, which is PA, times the whole secant itself, PB. We want to use this relationship to properly define the value of AB, because now we can still decompose this whole line segment PB, because we still talk about TP squared, so that doesn't change. Now PA is 3, but now notice that PB, which is this whole line segment from P all the way to B, that's equivalent to 3 plus AS plus SB. So notice that if I add these 3 line segments, I definitely have the whole length. But don't forget that AS is congruent to SB, which I'm just going to represent this as a value of X. So now we have 3 plus 2x, because every line segment, at least AS and SB, since they're equal, I'm just going to represent it with an X. And now we can definitely solve for this, because once we solve for this, AB from A all the way to B, well, that's just going to be equivalent to 2x, where we can gather the value of X from here. And the last hint that I'll be providing for this example is that notice that TP is perpendicular to PB, and OS is also perpendicular to the same line. So therefore, TP it's also congruent to OS. Hopefully with this information, you can have a better guidance to complete these problems on your own.